Next, we will hear from the operator project team who developed tools for risk exposure data analysis in the industrial workplace. The project is represented by Miguel Carvalho from UMinho, Hugo Gamboa from Faculdade de Ciências e Tecnologia da Universidade Nova de Lisboa, Mariana Dias from Nova de Lisboa, and moderating João Ferreira, software developer at Zenith Wings.
Hello everyone, thank you for being here. My name is João Ferreira. I'm with Mariana Dias, a scholarship student from Nova Science of School and Technology. I'm here with Professor Hugo Gamboa from FCT and Professor Miguel Carvalho from University of Minho. Through these projects, operator develop a risk exposure data analysis, tools for data analysis, combining concepts such as positive ergonomics, operator 4.0, and job quality indices by the Eurofound. Now our speakers will present the conclusions about these projects.
So good afternoon. I'll skip introduction. It was very well done already. I will just add Susana Brito, representing one of our end users, NEST Apparel, that is here in the audience and will be available also for questioning. And on video, we'll have also during the presentation the participation of Duarte Folgado from Fraunhofer and Professor Elazar Edelman from MIT. So in this consortium, we have 4 research entities, starting with Fraunhofer, University of Minho, Nova Lisbon, and University of Porto. 2 companies, Zenith Wings and Control Console, and 2 end users, Volkswagen Auto Europa and NEST Apparel, representing 2 different sectors of our manufacturing industry. We have also the participation of MIT with IMES, Institute for Medical Engineering and Science, led by Professor Elazar Edelman. We'd like to thank the MIT Portugal and the support of Compet and FCT to take this dream ahead. This is an old dream that we started some years ago, me and Professor Hugo Gamboa from Nova and Duarte Folgado. These MIT flagship projects allow us to bring the whole team needed to take this next step and bring other expertise, as you will see during the presentation, that were crucial for our goals in terms of products for our industry and for the European industry. So the problem that operator, or need that operator was funded and justified is the manufacturing industry. So it's a very important industry for not only national and European economies, representing 50 million direct jobs in Europe and 23% of active workers in Portugal. So this turned this manufacturing industry in a high relevant sector for these economies. To ensure competitiveness in this highly competitive market, these manufacturing industries have been having in the last years a large demand for digital transformation in manufacturing. But what we see in terms of the current approaches for most of the projects is that these projects focus a lot on productivity. They center their interest in terms of increasing productivity, getting the most out of the resources, the human and all the resources of the company, not addressing ergonomics deeply. Obviously, there are differences between different types of industries, and as you'll see, we have 2 different types of industries. Automotive industry, they also already consider ergonomics as important, but one very important sector for us, the textile industry and the apparel industry, ergonomics is not very well considered, and we see that operators, in the end of their life, they face lots of health problems, and they have bad ergonomics has impact in their productivity also. And cognition in terms of well-being of the operators is almost not even addressed in most of our manufacturing industries. So this will be the main innovation we have here. Sorry, I just saw a good friend I didn't see a long time ago. So the systems that need to be developed to address this problem or need of the manufacturing industry is that they need to be flexible. They need to assist in the shift from mass production to mass customization. And we need to do this by keeping not only the focus on productivity, but also in job satisfaction, having happier workers and healthier workers that will not fail, that will be happy to come to work and have no problems in the end of their life. So the digital transformation that we are seeking with this project, with our technology, the technology we are developing, is enabling a sustainable operations for this manufacturing industry. So our vision is to reconcile productivity, ergonomics, and mental well-being with the same level of importance. So previous approach, as I said, the current approach is focus a lot on productivity. Those triangles empty mean that some companies already pay some attention to ergonomics, but for the mental health of the operators, cognition, managers don't know if their employees are happy in the company, what problems they have, and the operators, they bring many problems to the workplace that will affect their performance and their colleagues in the team. So we are talking of industries that involve lots of human relationships. So our main innovation is to give the same importance to these areas of ergonomics and mental well-being. And because, as I'll say later, but I can already add now, they will also impact on the productivity. Happier operators will produce more, healthier operators will fail less because of healthy issues. So, as it was said before by my colleague, we are using three main features that innovative concepts. Positive ergonomics, not only to eliminate pain and discomfort, but also to provide and assure that we have a positive workplace for the workers. Operator 4.0, considering the new skills needed by Industry 4.0, and the Job Quality Indices defined by Eurofound. We managed to quantify some of these subjective indexes that Eurofound develops to monitor the quality of work. For example, the physical environment, the social environment. We'll have ways to measure these variables, also the intensity of work and the skills of the operators. All these affect their performance. So we have here an opportunity to digitalize the work study. This was a dream, an old dream of the past. How can we digitalize work study? How can we control the movements that operators are doing throughout the day and see deviations from what is the best method, for example? So, and the digitalization of some of these subjective means to track the job quality that we want for the company. And the methodology that we use since the beginning, participatory design with the inclusion of the workers since the beginning in the design of the project and in the design of the technology, interaction with the technology. And this allowed us to shift many decisions in designing the devices to interact with the operators. We developed a standard data acquisition and algorithm training that allow us, for example, to define and quantify the best method in time and in terms of motion. And with our algorithms detect deviations from this best method. When a company provides a budget for the development of a product, that budget is connected to the standard times that were calculated for that product. If the operator don't follow exactly that method that we defined, that took us to that cost, the company will produce the product with more minutes. That will affect their margin, or sometimes even provide loss for that order. They are working, but they may not be making money, for example. And also, this algorithm can allow us to detect fatigue in the operators. This was a huge development that we brought to the project in the connection with MIT. You will see this in more details after my colleague. Sorry, Mariana, you will talk for sure about this. I'm just trying to do an introduction in terms of the sensing technology used. You'll have more details after with Mariana. And a long-term trial in automotive and apparel industries. I will not talk about the problems we had in the last 3 years. We all know they were said before. COVID was a problem to assess these companies, and so this also had impact in our project, like it had before, like the other projects before. I bring again this diagram just to say that we want to establish a more balanced approach for cognition, productivity, and ergonomics. To say that if we have the right conditions for the workers to perform, if we are monitoring their risk in terms of repetitive motions, and in these industries, operators perform in short cycle operations very repetitive motions. If we don't have an alert, shift them and allow and advise them to change from operation, in the end of in a couple of years, they will develop musculoskeletal disorders and they will have problems, health problems. So ergonomics is very important. Having healthier operators, motivated operators, giving voice for the operators, they can communicate with us. You will see in more detail how they can communicate with us. It is also important. They know that we care about them. So they are coming happy to the workplace, healthier, they will produce more. So indirectly, we are contributing to productivity, and directly, we are also contributing to higher levels of productivity because we are monitoring the best method and we are monitoring the method throughout the day. So we have two use cases, two end users from two different types of industries. The textile and clothing industry, very important for Portugal, where we had contact with approximately 80 participants throughout the project, and the automotive industry with 70 participants. Despite being so different industries, they both face similar needs and similar problems. They both face increasing competition from emerging markets. The workforce is generally getting older, and they have difficulty in recruiting and attracting young people. So we need to find means to not easy, allow them to find workers and retain the workers, and not. This is a problem that's happening, especially in the textile clothing industry, because there are no employers. Some companies are stealing employers from other companies. But if I have a good and healthy workplace and happy workplace with positive ergonomics for my employees, they will not change for 50 more euros or 25. But sometimes it's just enough for them to move from one company to another. Both are interested in exploring these new ways to differentiate from their competition and show that they are concerned with their employees, they are providing better conditions for them to work. This is also is like a flag for them to attract new customers and better customers that are willing to pay more for the same minutes they have to sell. These companies, they sell minutes. So we just need to put value or more value on those minutes. So I briefly said already most of the advantages that we found for this industry, and we have advantage for operators and also for the industry, for the manufacturing industry. Greater motivation to work for employees because they feel they have a voice. They can communicate with us how they are feeling, if they have pain, if they are under pressure, if they have social pressure from their colleagues. So they have means to communicate with us, as you will see after. There is a sense of fairness in setting daily production goals, because the time that I will calculate, the production that I require from that operator, I took the sound off, but this doesn't, so I'm sorry. So the time is depend on their unique working conditions, and not an average. If I have a different machine, a different workplace, I also need to perform different from my colleague, because the conditions impact on the method. So there will be, they feel that I'm producing according to my resources. And the assessment to ergonomic risk and exposure to fatigue, this will allow them to have like a track throughout their life. What I did in this company, was I involved too much in repetitive operations or no? Now they will have a record that they can use later if they are with a problem, health problem, and insurance companies will say, no, that problem is because you were playing tennis, not because of being producing that constantly repetitive operation with short cycle. So now there will be a track that can be useful for these operators also. And obviously for the industry, advantages are more focused on productivity because productivity is connected to money, and that's what most interested to the industry. They will have tools with direct impact on improving productivity with methods digitalization, effective production management control based on new and their real condition. They can quantify now and detect opportunities to improve these operations because everything is connected to the conditions. And there will be a decrease in absenteeism because we are preventing operators having physical or mental problems. They are failing because they are not happy with their colleagues. They are failing because they have problems with their hands. So absenteeism is a problem for companies. They expect to produce this, and they don't have enough operators every day because they are absent. So, and also, as a manager, I would like to know if my employees are happy to work here with me. So they will have access to the mental well-being of their operators and to take decisions. If everybody in the production line is complaining about social problems, maybe there is something wrong with my supervisor. So I need to pay attention because they are not happy, they will fail, they may change, so I need to take action. If I don't measure, we saw before in the last presentation, what is not measured cannot be managed. So it's the same for us here. And I think I will pass now the word to Mariana Diaz.
Thank you, Professor. So Professor Miguel has just introduced you to the motivation of this project, its context, and I will, in the second part, go a little bit into more detail into how exactly did we tackle these problems and what results did we achieve in this journey towards the operator 4.0. So, as Professor Miguel said, one of our biggest goals was to contribute towards the digitalization of work study. But what is this work study? It is the examination of how we perform an activity. And what for? For improving the effective use of resources and to set up standards of performance. The question that arises is how can we do this using wearables and data collection? I hope that by the end of this presentation, the answer to this question would be more evident to you. To give you a quick overview of our typical data acquisition protocol, so by the start of the day, the operator we would collect data regarding the self-reported well-being, not only physical but also mental and emotional well-being of the worker. Then we would put on sensors regarding movement and physiological data in the operator. He would go to work and do his job normally, and by the end of the day we would ask him or her about the perceived workload in order to compare our quantitative data with the qualitative data from his perception. To do this, we use not only already commercially available devices, for example, for the physiological data, but also devices that were developed in this project. These were the devices that were developed in this project, and they can be divided in 3 domains: self-report, environment, and ergonomics, or productivity. The self-reports are those devices that should be at reach of the operator, and they have 3 buttons, each with a letter A, P, and D, which stand for apoio, pressão, and dor, which stand for support, pain, and pressure and pain. So anytime the worker, during his normal job, would feel the need for support, he would push the first button. Anytime he would feel too much pressure in work, the second one. And anytime he would feel pain anywhere in the body, he would press the third one. The environment sensor is somewhere in the workstation. It does not have to be at reach of the operator, and it's acquiring data regarding the temperature, the humidity, the luminance, and the noise of the workstation. Finally, regarding ergonomics and productivity, although these are two completely separate concepts, the sensors that are used to analyze both of these are the same and are movement sensors. And I will go into more detail on this one later on. All of these devices have a modular and extensible design in order to make them more adaptable for different use cases. The base is the Callisto, and the mezzanine is an extension of the first device. So these sensors need to be easily wearable. So we are in a factory setting. We cannot be for too long just putting the devices on the operator, and so we built these structures in order to make them more easily usable. This harness for the trunk, these bands for the arms and the wrist, and the gloves for the hands. Starting with the productivity analysis. So we, as I was telling you, used movement sensors, inertial sensors. And as we are studying the work in the industry, which is characterized by repetitive work, we can, from this movement data, segment this data and separate each working cycle. And from that, we can know how many work cycles did someone perform in a specific amount of time. From that, we can extract the productivity rate of the worker, and also we can compare how the worker is performing his job and compare it with a reference. We can know that the best way to do a certain task is characterized by a specific movement, and we can see the distance between the real movement and the standard one and see how we can improve the way that things are being done. Regarding the environment, as I was telling you, there's this device acquiring data regarding the environment of the workstation, and we can extract from that, for example, the maximum and minimum temperature that the worker is exposed to, the vibration and the noise, and from that we can know if the workstation is in compliance with the regulations, and if it is not, change it. Regarding the ergonomic risk, there is an operator with all the sensors, the movement sensors on. And from the information regarding each of the two segments, we can know the angular data. We can know the postures that are being done at each moment. So we have the ISO norm that establishes limits, healthy limits for each posture, and depending on the time and the number of repetitions that they're being performed. And we have these instruments that, from those norms, compute some scores in order to know if a certain task is risky or not for the human body. But this is usually performed manually and is very time-consuming. From our movement data, we can compute this automatically without any manual computation. For the physiological biomarkers, so here we jump into a different domain, which I haven't mentioned yet. Because we do not have such clear regulations and such clear rules for data regarding the cardiovascular function or the muscular function, we needed to do a pilot study in order to understand how could we create variables that were useful in order to study how the physiological state of the worker is at any moment during work. So we did this pilot study where we tried to mimic a repetitive upper body movement. with this task, placing a box in an upper and a lower shelf repetitively for 10 minutes and during 3 repetitions. Between each two sessions, there was a fatigue-inducing protocol in order to induce fatigue, obviously. From this study, we could extract some interesting patterns. For example, in the beginning of the performance of this task, people were not tired and they would have a very high synchrony between the chest and the abdominal respiration. Throughout time, as they get more tired, this respiration would be more desynchronized. Apart from that, we also found out that the physiological response to fatigue was very different from person to person. So it was not very easy to just say, oh, this person is tired from this point and not from the previous one, just using one signal or one metric. So we tried to combine all of this data, and we developed one model that would use all of these and was able to, with good accuracy, distinguish between a fatigue and non-fatigue state. Jumping again to the factory setting, it was while observing workers that we could see that the movement of an experienced worker was not exactly the same as a non-experienced worker. So an experienced worker would have a much more fluid and smooth movement. And from that idea, we tried to go deeper into the accelerometry data and try to see if there's any difference between an experienced and a non-experienced worker, and we found out that in a very specific frequency band from the accelerometry, we could find these little tremors in the non-experienced workers that were not present in the experienced ones, which are those higher waves that you see there. So from this we could, these tremors were called wobbles. From this we could extract this metric, which is the wobble count, and distinguish the expertise of the worker. But why is this important to know? Why do we care if there's wobbles or not? This can be a good metric for motion efficiency. And why do we want motion efficiency? Not only to be more productive, because as the movement is more efficient, the worker is faster and will produce more, but also in order to have less energy expenditure, because the worker will also get less tired. And for measuring better the motion efficiency, we used these 3 variables: smoothness, variability, and overreach. Smoothness is directly related with the wobbles, so the more smooth the movement, the less wobbles there are. The variability, a more experienced worker will vary less between performing the same task multiple times. And overreach, and a non-experienced worker will tend to adjust the movement many times and lose little pieces of time. And as Professor was saying, that these little pieces of time are very precious when we are talking about very repetitive and very fast work cycles. And in order to understand these differences, ultrasound images were used in order to check if these wobbles that we could see in the accelerometry data were really happening, and we could see the muscle. We could see that there was these contractions in the muscle. Well, in order to avoid these wobbles and customize feedback in training for the operators, we wanted to identify the positions of the joints that would lead to less wobbles, and for that some simulations were performed. I've talked about many different topics, many different things, but how does this all how is this all connected? Well, our output of the project is basically a very complex architecture with several layers. The first layer is in the workstation. It's the devices and the smartphones that acquire the data. Then we have the gateway layer, which makes the bridge between the devices and the server where the metrics are computed, and the final layer where these metrics are actually computed, and the dashboard as the final output. All of these layers are covered by the security and authentication layers to ensure privacy and security. And finally, our output can be represented by these images as these are dashboards that are both for self-tracking, where where each operator has his own data, and decision support dashboards with grouped data from many workers of the same workstation, for example, and where the manager can see and relate different scenarios and with the different metrics, and for example the existence of pain in a specific workstation where the postures are riskier, and relate all of these metrics in just one combined dashboard. I will now pass the word to Professor Wu.
And we joined an impressive team of researchers to conduct this work. So in MIT, we found the expertise on human physiology, so that could guide the perception that we had on the topics of fatigue, or where could we search in more detail to understand this process of learning from inexperienced workers to the experts workers. And some of the most advanced acquisitions were done in MIT with a strong connection. So we had then 3 PhD students that were in connection with MIT. Mariana will do soon a follow-up stay in MIT. Eduard just stayed for half a year in the lab of Professor Elazar Edelman. We were working with experts from here at Minho that knew how is the work environment, and also to reach and to interact and justify the needs of this technology in the factories. Professor Miguel was the keystone to guarantee that we understand well the needs of the factories and how can the technology that we are developing improve. And from Fraunhofer, the context of the work studies even in the questionnaires and the co-design of this device that Marianne was showing with the support, pain, was designed with the workers, understanding what would be the simplest device that they could use to report their day-to-day activities. And the Zenith Wings were supporting on creating the infrastructure to create all of this technology and creating these dashboards. We asked Duarte is delivering the thesis in this month, so you wanted to be here, but he recorded a short video of his stay in MIT, of this connection and the bridge that he was able to do, that I think will go now.
Hello, I'm Duarte Folgado. I'm a scientist at Fraunhofer Rijks and PhD candidate in biomedical engineering at Nova School of Science and Technology. Between March and June of this year, I was very fortunate to be a visiting graduate student at MIT under the guidance of Professor Elazar Edelman and Professor Brian Anthony. This short research stay was inserted in the context of the Operator project and financed by a Fulbright Award for Research. During my research stay, I was able to make significant contributions to my PhD and Operator projects. During those very active 4 months, working day to day with my lab colleagues, we discovered a new physiological phenomenon that relates movement expertise with physiological tremors. In short, we discovered that physiological tremors sensed using accelerometers during daily tasks can be used as biomarkers to measure movement expertise. We observed these findings in a controlled laboratory experiment. Still, we are confident about the practical implications of this discovery to support the training of manufacturing operators in industrial lines. This finding, coupled with a set of tools we developed within the Operator project, contributes to digital transformation in manufacturing. And its deployment in industry will contribute to a positive and lasting impact on the economy. Therefore, we'll surely be looking for opportunities to leave our controlled laboratory experiment and go to the field with hopes of established grounds for fundamental research with practical utility. Beyond the significant research accomplishments, what stands out most from my experience are the invaluable connections and friendships I forged. These relationships have endured, and our collaborations continue even after my return from the US. To conclude, I would like to borrow a quote from the renowned Portuguese poet, Fernando Pessoa. O valor das coisas não está no tempo que elas duram, mas na intensidade com que acontecem. Por isso, existem momentos inesquecíveis, coisas inexplicáveis e pessoas incomparáveis. Thank you, Professor Edelman, for the opportunity, for the Fulbright Commission, and for the entire MIT Portugal program.
So I will not translate the poem, but if anyone wants the English speakers...
We are truly a collaborative...
Sorry. Oops. I will link straight during lunch. And then we also have a very short context of Professor Edelman that was the one that welcomed this idea of bringing his knowledge to this field so he's a clinician, he knows, he's an expert on the human physiology, on the heart function, and could we also inspect these functions even in a factory? And we showed some impressive results, and it was inspired on some of the guidance that Professor Edelman gave, and a short comment from him.
We are truly a collaborative effort. There have been multiple PhD students now shared. People are traveling, even in the COVID era, back and forth between Portugal and MIT. We have high impact publications, and as noted, we're inspiring research topics to do what academicians maybe not have done as well before, to interact for those things that are relevant to industry. These experiments we know that we're doing will soon play their way into multiple domain spaces. We are truly a collaborative effort. There have been multiple PhD students now shared. People are traveling, even in the COVID era, back.
Oops. All right, thank you. And so some notes on the scientific output. So I've been this collaboration bringing many journal papers, many prototypes that we are generating, PhD theses that are completing, and some of them are still undergoing, and this put the possibility of interaction from our students, as you saw on the video of Duarte, has been a very notable result also of the project, and Mariana is on the way to also be, she's supported by FLAD to do this internship also in MIT. And with this, I end the presentation. We will be open to some questions.
Thank you. As Professor Hugo said, we will open now for some questions. I have some questions for you that I'm trying to connect the conclusions about this project with the main focus of this event, that is the research and its impacts in society. I will start with you, Mariana. Students often have the opportunity to work in actual use cases, like you did in this project, in the industrial setup. What were your biggest challenges, and what did this project add to your expertise and learning?
I think the biggest challenge was definitely moving from the idea domain and the planning to the actual doing, and especially in a factory environment where the rhythm is totally different. We never know how much time we will have to prepare the operator, to give them the context of the project, and to communicate the best way we can, and with the short time that we have, everything that we want to do in that short amount of time. And for sure, it was a great opportunity for a student like me to know what it is to try at least to make science for a purpose, and to know that it will that at least we're trying to have an impact on someone's lives, and not just standing in our laboratory thinking we want to improve people's health and from a distance. We were there, and we wanted to really know what were their needs, and from the industry and from the workers, and try to work on that and develop what is really necessary.
Okay, thank you, Mariana. I have one more question to Professor Hugo. How did the FFCT manage to leverage the R&I with this project that wouldn't be able to do otherwise without it?
Okay, so we work in the lab environment in the context of measuring or creating new devices to physiological measurements. And this opportunity to go out of the lab, as Mariana was saying, changed a lot the perspective. Even the impact of the research that we are doing, we understood that some of the measurements that we were performing may have a strong relation and strong impact on the day-to-day life of the management of a company, of the workers that are being exposed to this monitoring technology. And we understood that three main areas of application to the bringing from the academia to the real factory were strongly important. One was teaching someone to do better their work, and we have tools now to help on the operators to improve. They can measure information and track this information in a self-improvement mechanism. The other way is to the safety of the operator. So we now have measures that are able to guarantee that the person knows that it's doing wrong movements, that they should change their work practice. And for the factories, this global approach to the cognitive and the productivity and ergonomics may change the day-to-day practice that they have with their workers. So it was being able to transport this information to the real environment was impressive.
Thank you, Professor. I have one more question for Professor Miguel. The projects at the university level are sometimes a bit challenging to implement in a real use case, such as an industrial setup like we saw in the presentation. How do you see the results, the impacts that the results have in the people that experienced it?
Yeah, as Professor Hugo said now, and in my last slide also talked about a little about those advantages both for the operator and for the industry. University of Minho has a strong connection with the industry around it, and we are known to be in close contact with the industry. So we are not only working in the laboratory, we are working also in partnership with the company, with the enterprises, and we can understand and perceive the problems and their needs. In this project, we saw two opposite reactions, but the negatives I believe are more connected to our culture, the way we are working in terms of in Portugal. Operators were very happy to be able to know that they could communicate, express what they were feeling, if they were happy or not, if they were under pressure. So this was a positive result that we felt, that they had a voice. And till then, nobody cared about them. They were just coming to work and start working and go away, and the managers would not talk to them. So now they feel they have a voice. We also had a reaction that they were feeling, some of them were feeling that they were being like controlled. Any emotion that I'm doing is being monitorized. But this is, in my opinion, this is the way we need to change this mentality in our industry. When we are trying to improve the method to the operator, is not to make him working more, is just to put him, making him working better. And this is what we need to change and explain and train, and a change in mentality in the industry, because when we come with new things to implement, there is always resistance. This is typical from Portuguese, but not only Portuguese, I believe, but we are keen on that, and everything that comes new, no, not here, here doesn't work, we are special, everybody works in a unique way, or believes works in a unique way. So we need to change this mentality in order to take the most advantage of these technologies, because they are coming to help us, not to make us rush and run. We don't want operators to run. We want operators to perform healthier, in healthier conditions, have a voice, feel well, and produce more with less effort.
Thank you, Professor. I have one more question for you. You said that the Min University is very close to the industry, and of course has a lot of partnerships. And how do you consider, how much important do you consider these close collaborations, particularly with MIT? How do you see it?
I think it would not be possible to take this to the level that we took, and as Professor Hugo said, presented before, we learned from MIT new ways, new biomarkers that we could use to monitor performance. And I would take this just example of the wobbles. We never thought about it, and during our continuous and regular meetings with MIT, we learned they were already doing this with the dancers. So now we have a way to monitor an experienced worker and see how fluently he performs that operation, wasting less energy. And now we can train new operators to perform as the experienced worker, and detect where these new workers are wasting more energy, what they are doing wrong to not be as good as the experienced one. So we can also we see here a high potential in a tool to train new operators. And the industry strongly needs that we train new operators and good operators. So it would be a shame if you don't take operator to a next level. Yeah. You are not going to ask, but I'm going to say, we really want to take the project in the next level, and partners are welcome to invest and take the products out to the market.
Thank you. I have just one more question to Susanna. Hello, Susanna. Thank you for being here. You are representing a company that took part of the project, and we can say that, like all companies, you have factors that you consider that can be improved or even solved. How do you expect that operator can impact your employees?
So first of all, it was a pleasure to be part of this project and to be here today. NST is a clothing factory producing a wide diversity of premium products to high-end and luxury brands. So the environment is very stressful. Miguel knows us very well. So the impact that the operator has on the workers, like Miguel said, was they felt visible. They felt happy to be on our focus. So our goal is to have happy workers. So it was a win-win perspective. So studying work methods provide us valuable insights into optimizing the process and enhancing efficiency. So it's clear for us the importance to to proceeding with the research and development of this project.
Thank you.
Thank you.
Thank you. I will, if anyone in the audience wants to ask.
Thank you for the very interesting presentation. So my understanding of your research is that you're looking at how to improve the mental and physical well-being, ergonomics, et cetera, of workers in manufacturing. So my question is, how will your research evolve to reflect the increasing automation of manufacturing and manufacturing tasks that are, performed more by AI, robotics, et cetera? Is there room in your research, for example, to transfer what you're measuring to human workers in an office setting or not in manufacturing? Thank you.
The key of the project was on the manufacturing environment. So we do have in our labs more office contexts that are in a different scenario that we've been working. One of the topics on this transformation of more automation is that we'll still have several generations of workers that need to be well supported, and they are getting older, and might be that the support needs to be even more intense. So to give dignity to the last years that we will work in a factory. So this aging operators is also one concern that we took care on the project that I think goes in the direction that you were driving. Some of these measurements can also be done on the desk workers, that I think is more similar to the ones that now you are sitting workers, but the desk ones we also measure some physiological day-to-day intervention that it's a follow-up of the project that even if in the context of the several partners we are following up.
Anyone else?
Sorry to monopolize the questions. Congratulations. It is a very important project. It was one of the best things I've seen so far in this morning. Being from industry, heavy industry like the one I work in, I think that we normally tend to see workers as machines, that we treat them worse than machines, because we have much more condition monitoring for machines than you have for workers. And you need to have a lot more of condition monitoring that you are trying to set up F2. I think that the most important thing I saw here, and I urge you to pursue in that research, in that development, is the mental health of the workers. We know that ergonomics is there for ages. We know that you can monitor ergonomics. We can take pictures, we can take 3D videos, but these ECG things, especially the mental health of the persons, the stamina that the person has when he starts working, there are physical stress on the worker, especially if you work with high payloads, depending postures, but the mental stress of working on an industrial environment every day to meet goals, to meet production goals, to deal and tackle with the pressure that comes from the market and the competitiveness has not been properly measured and attained to the conditions of the workers. And the workers do not need to work more, they need to work better. More is a result of the better work. And that is something that I fully agree with you, Professor. We need to change this mentality. We need to work better in all sense, with quality and health and productivity. Thank you very much, and congratulations for your project.
Thank you. Yes, no more questions. So, thank you.